In this video, we're going to have a look at trig equations. So a lot of the time, trig equations will have more than one solution. So let's have a look at a few examples. We're starting with these two. So our first one says solve sine theta equals minus 1 on root 2 within the domain 0 to 360 degrees. So it's always really important that we pay attention to that domain. Alright, so sine theta equals minus 1 on root 2. The first thing we're going to do is draw ourselves a little diagram. So we know we've got all stations to central. Now if sine is negative, that's going to be in one of these two quadrants here. Then we can use our special triangles and our exact values, and we can figure out that our related angle is going to be 45 degrees. So that means because we're going between 0 and 360 degrees, that theta is going to be equal to 180 plus 45 degrees, which would be 225 degrees, or 360 minus that 45 degrees, which would be 315 degrees. So there are two values for theta that satisfy that equation. Our second example asks us to solve cos theta equals 0 between that same domain, so 0 to 360 degrees. Now cos theta equals 0, that's not an exact value, it's one of the ones that we're going to have to read off our graph. So our graph of cos starts up here at 1, comes down, drops down to minus 1, and comes back up. So it crosses at 90, reaches minus 1 and 180, then it crosses again at 270. So we're looking for when cos theta is equal to 0, so that's these 2 points here. So it's going to have theta is equal to 90 degrees and 270 degrees. So within that domain, we have two solutions for theta. Right, our third example asks us to solve cosec theta equals minus 2 within the domain minus 180 degrees to 180. So our domain's a little bit different this time, so we're going to have to be careful with that. And we've also got cosec theta equals minus 2. So that's one of our reciprocal ratios, and as often as we can, we try and transform that back into one of the ratios that we know. So cosec is related to sine. So instead of having cosec theta equals minus 2, we can write sine theta is equal to the reciprocal of minus 2, which is minus a half. So then we can draw our diagrams and figure it out. We know that sine is negative, so that's going to be our third and fourth quadrants. And from our related angles, we're going to have 30 degrees. So we've got 30 degrees here, and we've got 30 over here as well. Now where this domain comes into it, we're not going to read anti-clockwise like we usually do. We're going to read in two different directions. So from 0, we're going to read around this way to 180. And then we're going to also read around this way to minus 180. So because both of our angles are down the bottom, they're both going to be negative angles. So we're going to end up with theta is equal to minus 30 degrees. And also, if we come all the way around to this one, that's going to be minus 150 degrees. So those are the two values of theta that satisfy that equation within our given domain. For our fourth example, it asks us to solve the square root of 2 cos theta minus 1 equals 0 for our domain 0 to 360 degrees. So this equation here, we're going to rearrange it first to get that cos theta on its own. So we're going to add 1 to both sides, and then we're going to have to divide through by root 2. So cos theta is equal to 1 over the square root of 2. So if we draw our diagram, we've got our all stations to central. Cos is positive, so it's in one of these quadrants here. And we know that our related angle is 45 degrees. So between 0 and 360 means we are going anti-clockwise the whole time. So we're going to end up with theta equals 45 degrees. Or theta equals 315 degrees. So those are the two that satisfy that equation. Right, our fifth example asks us to solve tan squared theta equals a third for our domain 0 to 360 degrees. So this one's a bit different because it's got that squared term in there, so that's what we're going to get rid of first. So to get rid of tan squared and just make it tan theta, we're going to have to take the square root of both sides. But we need to be careful when we take the square root of something, we always end up with positive or negative, whatever the answer is. So tan theta in this one is going to be equal plus or minus 1 over root 3. So then we can draw our little diagram. It's actually going to be in all 4 of our quadrants this time because of that plus or minus. And our related angle is going to be 30 degrees. Oops, that didn't quite cut through where I wanted it to. But we've got 30 degrees in each of those. So we're going to end up with our theta equaling 30 degrees first off. Then if we come around to this one, that's going to be 180 minus 30, which would be 150 degrees. Then we've got our 180 plus 30, so 210 degrees. And our last one will be our 360 minus 30, so 330 degrees. And our very last example asks us to solve cos theta minus 50 is equal to root 3 on 2. And I've just realised I haven't written a domain for that one, but we'll just go between 0 is less than or equal to theta is less than or equal to 360 degrees. Alright, so with this one, it's a little bit different because we've got that theta minus 50 in brackets there. So what we're going to do, we're actually going to make it look a little bit nicer. We're going to write let u equal theta minus 50. So we're going to replace that whole theta minus 50 just with the letter u for now. So we're going to end up with cos of u is equal to root 3 over 2. But if we've changed that, then the domain of u isn't going to be the same as the domain of theta, because they're 2 different things. So if our domain of theta was between 0 and 360 degrees, but if u is theta minus 50, then we're going to have to subtract 50 from both ends of our domain. So the domain of theta minus 50 would be greater than or equal to minus 50, and less than or equal to 310 degrees. So we can write it as u as well. U is less than or equal to 310 and greater than or equal to minus 50. So now we can solve this like we were solving our earlier examples, but we're solving it all for u and in this new domain. So if we draw our diagram, cos is positive, so it's going to be in one of these quadrants here, and our related angle is 30 degrees. So looking with our boundary, we've got our 30 degrees, and we've also got minus 30 degrees, because our domain starts at negative 50. So our solutions for u are going to be u equals minus 30 degrees, or u equals, oops, don't need that bit, or u equals 30 degrees. But we don't want u, we want to solve for theta. So if u is that, then theta minus 50 is equal to 30 degrees or minus 30 degrees, which means that theta itself, we're going to have to add 50 to both of those answers. So theta is going to be equal to 20 degrees or 80 degrees. And you can always put all that back into this top equation and make sure that it makes sense as well. But those are a few examples of solving trigonometric equations.